Okay guys, I'm going to do a video going through all of the odds of the review packet, so if you need help this would be a good resource for you. So let's start on the front. We're doing the odds. It says which two sets of construction marks labeled 1, 2, 3, and 4 are part of the construction of perpendicular bisectors. So let's take a look. Actually, let me grab a compass so we can see. If I were to do this problem, I would put the bullseye on the end point, and I would open this up to a certain amount. Okay, and I'm picking it a certain way for this go around. Oh man, and my pencil's not sharpened. 1 second. Okay, now I have a sharpened pencil. So I would put my bullseye on this end point, and then I would open it, and I make this big arc. You should notice something already. Then I switch the bullseye to the other side. Another big arc. So if I'm doing a perpendicular bisector proof, do you notice which ones it's going to go through? Yeah, it's going to go through 1 and 3. So 1 and 3. Okay, let's keep going. Number 3. Which illustration shows the correct construction of an angle bisector? So when I have an angle bisector, let me just draw a little picture here on the side. The first thing that I normally do is I make an arc so that it crosses both sides. Right? Then from each of the intersections I create, I make my X marks the spot. Right? And then through my X marks the spot, I draw a line. So we got to figure out which one looks like that. Well, this is missing the arc here, so that's no good. This is missing the X marks the spot. This is missing a lot of things. But here's my arc across and my X marks the spot. Number 5. Classify the following triangles as equilateral, isosceles, or scalene. So here's a couple things to remember. Equilateral means 3 sides, like all the sides are the same. Isosceles means at least 2 of the sides are the same. And scalene means none are the same. So I need to figure out essentially the length of this side, and this side. So let's start with ZX. You guys need to know the distance formula at this point. If you don't already, you need to memorize it. Okay, so remember, I'll do it the first time. So it's the x's. It doesn't matter if you do x1 or x2 first. Then we're going to do the y's. Okay. Well, let's figure out what these points are. So on here, I'm going to just draw it real fast. X is at over 4 up 2. Y is at over 2 down 2. And Z is at backwards 2 up 0. So we're doing from Z to X, so these up here. So I'm going to subtract the X's. So the X's were -2 and 4. And now I'm going to subtract the Y's, 0 and 2. Okay, so -2 minus 4, that's -6. -6 squared is 36. -2 squared is 4. So this is the square root of 40. Now I'm going to do from X to Y. Now guys, you should probably do this on another piece of paper. Okay, we're going to do a difference in the X value. So I'm doing between X and Y. The X's are 4 and 2. A difference in the Y's. So 2 minus a -2. That's going to be 2 squared, which is 4. That's going to be 4 squared, which is 16. So this is the square root of 20. I did between X and Z, between Z and Y. Now I have to do between Y and Z. Okay, so between Y and Z, the X's are -2 and 2. The Y's are 0 and -2. That's going to be 4, so -4, squared is positive 16, because we're doing -4 times -4. It's going to be a 2 squared, which is 4. So that's square root of 20. So you'll notice my lengths are square root of 40, 20, square root of 20. Are all of those the same? Two of them the same, or none of them the same? Well, two of them are the same. That means this is going to be an isosceles triangle. These are the same process you'd have to do between A and B. So if I'm going to start 7, we're not going to do all of it together, but you're going to find the distance between A and B. You're going to find the distance between B and C. And you're going to find the difference between A and C. Because if I were going to draw this triangle out, I'm just going to give you a generic little picture. A is over 4 up 5. B is backwards 2 up 3. And C is over 0 down 1. So I have to find the distance between A and B and C, and A and C. Okay, let's move on to number 9. If we're solving for x, it would be helpful to remember that all 3 angles inside of a triangle add up to 180. Okay? So this first angle is x plus 44. Then we have 80. My last angle is 60. First, I have to combine my like terms. So there's only one x term. It's just x. 44 plus 80 is 124. Plus 60 is 184. I'm going to subtract 180 on both sides, and that gives me -4. Now, you might be thinking, wait, -4 is a weird value to get for x. Well, it's actually okay that it's negative, because if I plug it back in here, I'm going to have a -4 plus 40, and that gives me a positive 40. So that angle measure is 40. So x can be negative as long as when I plug it's positive. Okay? Let's do number 11. When I have an angle on the outside, my goal is to use the exterior angles theorem. Okay? And the exterior angles theorem tells me that my exterior angle, so this thing here, is equal to the sum of my remote interior angles. So these are interior angles. The remote ones are the ones that aren't directly next to it. So this angle is adjacent. That is not a remote interior angle. The two here and here are my remote interior angles. And my rule just tells me that my exterior angle is equal to the sum of the remote interior angles. So I have that 115 is equal to question mark plus 60. If I subtract 60 on both sides, I get that my question mark is 55 degrees. Let's do number 13. Here's my exterior angle. This angle is the one directly next to it. It's adjacent. This is not a remote interior angle. It's the other two here and here. So this is equal to this plus this. And again, this is just a rule you have to learn. So this thing on the outside is equal to 42 plus this. So 42 plus 4x minus 6. Well, first I have to combine my like terms. I have a 42 minus 6. That's going to be a positive 6. I'm going to subtract my 4x on both sides. I'm going to end up with a 5x minus 4 equals 36. I'm going to add 4 to both sides. And when I divide by 5, I get x equals 8. Okay, these are some of my favorite problems from this unit. It says we're ordering a triangle's sides or angles by size. So 14 is we're doing odds. So sum number 15, order the sides of, this is from triangle LMN from shortest to longest. So we have a rule that tells us that the shortest side is opposite the smallest angle. So if you notice, this is my smallest angle. It's opposite my smallest side. This is my largest angle. It's opposite my largest side. This is my medium angle. It's opposite my medium side. So it asks from sides from shortest to longest. So the shortest side is LM. The medium side is MN. And the longest side is LN. Now, this is saying segment. This is segment, comma, segment, comma, segment. We could also write it in terms of its length. Remember, if I take the bar off the top, we're now saying the length of segment LM. Well, the length of segment LM is less than the length of segment MN, which is less than the length of segment LN. So you could write it either of these two ways. Let's go to the next page. (17) says in triangle DEF. So let's start by drawing triangle DEF. So we name it by its vertices. So there's D, there's E, there's F. You could put it in any order. It could be D, E, F. Just need to label the 3 vertices. But what does matter is DE has a length of 12. So the segment DE is 12. The length of segment EF is 6. And the length of segment DF is 8. Since this is my shortest side, this is my smallest angle. Since this is my medium side, this is my medium angle. That means this is my largest angle. So if I'm listing from smallest to largest, my smallest is angle D, my medium is angle E, my largest is angle F. But we could also do it in terms of its measures. So the measure of angle D is less than the measure of angle E, which is less than the measure of angle F. So you could write it either of those ways. Let's move down here. You notice 19 says that the angle ACB, so angle ACB, so this angle here, is the same as angle B, that's this angle here, which is the same as what else? Well, you'll notice this is an equilateral triangle, which means all 3 of the angles in it need to be the same, so it's equal to angle BAC or CAB. Let's look at this one over here. We have to use isosceles and equilateral triangle rules. So let's see what we can figure out. We're going to do both of these. So it says AB is the same as what? So this one here is the same as what? Well, we know it's the same as BC, but we need to use our isosceles triangle rule. So you'll notice, and this triangle, this angle is the same as this angle, which means this side has to be the same as this side, which means this one will also be the same as this. So it's going to be BD. Okay. Well, now we're over here. It says angle C is the same as what? Well, yes, I know it's the same of these. They're already marked, but I need something in the same triangle. Since this side is the same as this side, the angles opposite them will also be the same. So if this is angle, so angle C will be the same as angle D. Okay, let's move on down here. I'm actually going to do a handful of these, or at least get them started, because I think these are a little tricky for some of you guys. The first thing we want to do is identify which type of triangle it is. This is an equilateral triangle, which means all of the sides are the same, which also means that all of the angles are the same. And we said in class, if all the angles are the same, if it's an equilateral triangle, that means that each angle is 60 degrees. So this angle is 60, this angle is 60, this angle is 60. So if this angle is 60, it's also represented as 2x plus 10. I'm going to say that 2x plus 10 has to equal 60. So I'm going to subtract 10 on both sides. And there's x equals 25. So let's look at number 23. This is also an equilateral triangle because I know that all of the angles are the same. It showed me that this angle is the same as this, which is the same as this. That means all of the sides are the same. Specifically, all of the sides are 2x. So let's look at the one that has a number. If this side has a length of 24, that means this length also has to have a size of 24, and this length also has to have a length of 24. So see if you can finish that one now. Let's move on to number 25. Let's see what we know. We're going to be using isosceles and equilateral triangle rules, and it looks like I have 2 isosceles triangles. So if we look at this one here, this is the same as this, which means if this angle is 50, then that angle P has to be 50. Okay. What we're just going to start doing is solving for anything that we know. Let's look at this angle here. We know that these three angles have to add up to 180. So I'm going to have 50 plus 50 plus something equals 180. So I really have 100 plus something equals 180. Well, that something has to be 80. Lastly, these two angles are what? Oh yes, they're vertical angles, right? It's from our other units. You still got to keep that vocabulary fresh. Okay, so if this is 80, this is 80. Let's take a look at number 27. We have two isosceles triangles. You'll notice down here that these sides are the same, which tells me that the angles opposite them will also be the same. So if this is n, then this also has to be n. Well, if we have n, and 90, we know that n plus 90, those three angles have to add up to 180. So I have 2n plus 90 is 180, which means 2n equals 90. So n equals 45. Okay. You'll notice they also showed me that this angle has an arc here and this angle has an arc here. That means they're the same. So if this was 45, that means this has to also be 45. Also, if this is an isosceles triangle, then this angle has to be the same as this angle. So if this is m, this is also m. So now I can say that m plus 45 equals 180. Okay. I subtract 45 on both sides. And then I divide by 2. I get m is 67.5. Now, a lot of people have been asking me, Mrs. Barnes, can I have a decimal? You can almost always have a decimal in your answer. Maybe there's some rare cases where we don't, but decimals are fine, okay? They're still numbers. They're values. They're my value in this case for the for m. So that's good. Okay. I'm going to stop this movie, and then I'll do the last 3 pages in a different one.